how's it going? So just like a Hollywood movie, huh?
We love that. Thank you.
Yeah, just like a Hollywood movie. So my name is Cody Bahlau, and this is Dr. Oja, and we're here to talk to you today a little bit about what we do on a modern research vessel. So I hope you have your questions ready to go. I know we saw quite a few from Miss Lacroix already, so I know you guys have quite a few questions. But before we sort of start talking about some of the science we do, let's first talk about where in the world we're at. So we work on the Marcus G. Langseth. It's a research boat run by Columbia University out of New York City. So not too far away from where you guys are at right now. So let's add Google Earth and let's see where in the world we're at. So hopefully this should look familiar to you guys. This is your school. Hopefully I picked the right one. So as we zoom out, this is Google Earth, remember? So we see Baltimore here. So let's keep zooming out a little bit farther. Come out a little bit farther. Here we see the East Coast of the United States. Remember, this is the Atlantic Ocean here, of course. Here's the US. So we're working all the way down here, south of Mexico. So Mexico is here. We keep coming in a little bit farther. And this is our current work area that we're doing our scientific study. So we're doing our different types of data collection here, just south of Mexico, near Acapulco. And as we come in a little bit farther, you can see a couple different lines here. So the red lines, the blue lines, and the green lines are the lines that we're currently acquiring data. So what does acquire mean? Acquire means that we go out with a set goal, and we want to gather or get scientific data over that particular area to later go back to the laboratory or the office or the processing center or the computers and be able to understand more about the Earth underneath the ocean. Would you like to jump in, Doctor?
Yeah, no, it's this is my first time on this ship. It's amazing, and we're collecting all kinds of data. And in a little bit, maybe we'll be able to show you some really cool data we've been gathering. But yeah, it's much warmer than Baltimore. I know you guys got snow, but I'm a little jealous of the snow. But it's really nice here too.
Yeah, it's 85 degrees, sunny every day. Hardly any wind. So as I mentioned before, so we're on the Marcus G. Langseth. That's the boat that we see right here. So if I zoom in, you can actually see our current location. And this yellow line is our 24-hour track. So that's the last 24 hours. That's where we've been. So now I've talked about the boat a couple times, the Marcus G. Langseth. So let's go into a little bit more detail about it. So a football field is 100 yards long. So the boat that we're on now is 75 yards long by 20 yards wide. It holds 40 to 45 people, somewhere in there, and we can go offshore or we can leave land and go out to sea for 40 days at a time. So I don't know how many people in your class there, maybe 25, 30 people, maybe 25 people. So if you double your class, that's the amount of people that we have on board. So let's watch a drone video of the vessel so you have sort of a better understanding of what that looks like. So here we go. Let's fly over. So offshore, we have all these different names that we use to describe a boat at sea. So right now, we're coming up on the back side of the boat. That's called the stern. So that's the back of the boat. Now remember, this is 75 yards long. Now we're coming on the right-hand side, or we call that the starboard side. And I don't know if you can see it, but right there in the center of the boat, that gray square, that's called the A-frame. And we're going to talk a little bit more about that in a little bit. So as we come to the front of the boat, that's called the bow. So that's where the captain and the bridge officers, they're up on the bridge and they drive the boat and they navigate to make sure that we don't hit anything when we're sailing the seas. So you can see just below that blue stripe on the top, there's some windows, and that's where the captain works. Now we're coming along the port side, or the left side of the boat. It's called the port side. And right in the center, you can see a big tower. And that's where we have biologists work. They look for sharks and whales, dolphins, turtles, seabirds. And we'll talk a little bit more about them in a few minutes. Now we're coming on the back side again. And here we see the stern. And I don't know if you can see all those cables that we have in the water, but that's where we've deployed scientific equipment into the water. So what does deploy mean? Deploy means we take something that's on the boat and we put it into the water. Sometimes it's attached, sometimes it's not. And we're able to gather data through these different pieces of equipment that we put into the water. And we're going to talk a little bit about seismic here, right now. So do you want to talk a little bit about seismic? I'll pull the lens in.
Sure, yeah. So seismic is basically a fancy word we use to basically look what's inside Earth, right? So if you have a family member or yourself, maybe once upon a time you've gone to a doctor and got on like an X-ray scan, that's essentially what we're doing. We want to know what is happening deep underwater inside Earth. So that's we'll maybe show some videos later how we do that, right?
Yeah.
But yeah, maybe we can just show them an example.
And sort of another way to think about it is you know how a bat flies through the air. So as a bat flies through the air, it sends out a noise, and then it gets the reflection or the echo back. And then when it sees that, it's able to make a picture sort of the trees, of the barn, of a house, of a building based on that echo. So we sort of do the same thing with seismic. And we can make, as Dr. Oja said, we can make a picture of the rocks below the water. And if you think about it like this, so if you have a birthday cake, so let's look at an example of a top-down birthday cake. So let's go back to Google Earth. So here's Google Earth. So right now, if you have a cake on a table, we're looking straight down on top of the cake. So that's what we see here on Google Earth. So does everybody see these three mountains in the water? Yeah. So these are three volcanoes that we see here. They're underwater volcanoes. So if you remember, we're looking top down, but when you cut a cake in half and you move it away, you can see the layers. You can see the cake, you can see the frosting, maybe a little, maybe some sprinkles if that's what you like, maybe another layer of frosting. So when we do seismic, that's what we're doing. We're cutting away that piece of cake to be able to see sort of the layers of the rock. So does everybody see the three peaks, the three red peaks here? Can you raise your hand if you see them? Yeah. So those three red peaks are those three volcanoes that we just looked at, but we're looking at them at what's called a cross section. So we're looking at them from the side, and we can see the different types of layers of the rock. And with this information, we're able to learn about plate tectonics. We're able to learn about how volcanoes form. We're able to learn about sort of how earthquakes happen at the different fault zones. I don't know if you've learned about plate tectonics yet. I'm sure you have. But if not, we can talk about that in a little bit. You want to show the picture of the...
Yeah, let's show them the picture of the volcanoes.
So on top of the seismic, we also have a system on board called a multi-beam sonar. And with that, we're able to make very detailed images of the ocean bottom. So here's one video that we've made. Hold on one second. Let me load it. So these are of the three same volcanoes that we just saw a little bit ago. So let's watch this. So these are these three volcanoes that we've looked at, but this is just another way to be able to look at them with high resolution, sort of a picture of the bottom of the ocean. And one real interesting thing about this is when you look at Google Earth or when you look at a map, you think, oh, well, most of the world has been mapped. You know, you can look at the globe. It shows sort of mountains in the ocean and things like that. But in reality, only 27% of the ocean floor has actually been mapped. We know more about the surface of Mars than we actually do our own ocean floor. So one of the things that we do on this type of scientific expedition is we also map the ocean floor as we study other things as we go.
And just one thing to think about, right? So what you guys just saw, these volcanoes, right? These are thousands of meters below water, right? So that volcano that you just saw, that was 5,000 meters below the water, right? So next time you go swimming, think about it, right? If it's more than 10 feet, you're going to drown, right? I mean, it's very deep. We're talking about 5,000 meters. So basically, very, very deep. And the other thing is, think about all the humans that have lived on Earth. Right, your father, your grandfather, your great-great-grandfather, going all the way back to hundreds of thousands of years. What you just saw right now, no one ever in the history of humanity has ever seen that until you guys. We are the first one to see these volcanoes at that resolution. Our forefathers, our grandfathers, they had no idea this was even happening. So you guys are really the first one. So it's a pretty big deal, right? And there's a lot of interesting science that comes out of it. But even if you didn't care about science, just exploration wise, you guys are the first ones to be able to see something like this.
Yeah, 100%. Yeah. And 5,000 meters is what, roughly 15,000 feet. So it's very deep. So let's stop here for some questions. We don't want to go too far in case anybody has any questions. Let's break for questions for a few minutes.
Yeah, first we were commenting on the images. Some people were like, "Wow, it looks like the moon." Questions, Tyrell, go ahead.
Okay, so my question is like, how long did it take y'all to like get all the way over there, and like when did y'all leave Baltimore to go?
Yeah, was that Tara?
That's Tyrell.
Tyrell, that's a nice question. It's a good one. So we're gonna pull up the map and I'll show you. So we left out of San Diego, and how fast do you think the boat goes? Let's guess.
50 miles. 20, 30. 75. 6 miles per hour.
6 miles per hour. Okay.
So 6 is pretty close. So our max speed is 10 miles an hour, or we call it 10 knots. That's as fast as we go. But remember that we travel 24 hours a day. So 10 miles an hour, 24 hours a day, roughly 240 miles a day. So we started in San Diego. Which is right in here. And we sailed down. So let's throw a little path here as we go. So San Diego, somewhere in here. So we came along the west coast of Mexico. And then we came down to Manzanillo, which was a port in Mexico, which was right here. And then from there, we sailed so roughly 1,500 nautical miles from when we sailed down. So it was about 6 or 7 days for us to get to San Diego down to our work area. And when we go home, we're going to leave our work area here, and we're going to go back to Manzanillo, which is about a day's sail away, 26, 27 hours away. Yep, that's a good question.
You guys don't know all about the 6-7, but you said a lot of 6-7s in there.
Oh, that's true. Yeah.
All right. Other questions, Ruby.
Does the volcanoes underwater have like any effect on the climate in the water too?
So sorry. So just Michelle, can you repeat that question?
So that was from Ruby. So the question was about do the volcanoes in the water have any effect on, I guess, the climate, maybe specifically the temperature in the water?
Yeah, so the temperature of the water is strongly affected by these volcanoes. And so if you think about it, I know a lot of you guys are interested about life on other planets or life, right? And so when we look at our own history of life on Earth, one of the things that we keep on finding is that those volcanoes might have been the first place where life came about. There's the acronym that we use. It's called last universal common ancestor, right? So that's the last common ancestor you and any other animals, may have had. And we tend to think, we know that that thing was probably most likely came from something that used to live in hot volcanoes like that. We call that hydrothermal vents, for example, sometimes. And even right now, when we go to Mars, for example, or in a couple of years, we're going to go to one of the moons of Jupiter called Europa. The place where we would want to go and look for maybe alien life are volcanoes exactly like that. Yeah, so it strongly controls the temperature, and it's also a very good place to look for life.
Yeah.
Awesome.
Yeah, good question.
Other questions? My friend in the red.
My question is, how far away from shore?
question was, this is from James. How far away from shore are you?
So right now, James, we're, let's see. Right now we're 38 miles away from shore. So if we went full speed, roughly 4 hours. But right now we're actually working pretty close to shore. A lot of the times we work a lot farther out. So sometimes it could be 1, 2, 3, 4 days away from shore. So what does that mean? So think, if you're sick or someone gets injured, that's a long ways away from help. So we have a lot of things on board the boat that we help prevent accidents. And if something does happen, we can mitigate it. And we're going to talk about one of those things next when we look at sort of the details on the inside of the boat.
Awesome. Maybe we'll take like 1 or 2 more quick ones. Vicky.
So you know how volcanoes shoot smoke when they erupt inland? Well, what happens to them when they're underwater?
This was a good question, but Vicky, I'm not sure if you heard, but again, we're wondering, on Earth, we know that volcanoes are going to erupt. They're going to emit smoke. They're going to emit lava. What happens when they erupt underwater?
That's a great question. And honestly, we don't know a lot about it because, we know a little bit about it. Part of the problem is because they are so deep and so underwater, we can't always see them, right? We don't even know when they go off. But the few times, the few times that we actually can see them go off, there's a lot of gas that comes out. There's a lot of hot water, hot plume that comes out. And, depending on the kind of volcanic eruption, we might get like these lava that come out and then they instantly turn into solid because they're getting cooled by water. So kind of like what we see on Earth, but think about putting like something really hot in water. It cools very, very fast. And you get a lot of like hot water and steam from those volcanoes. But yeah, great question. But unfortunately, we don't see them all the time because they're so deep underwater.
All right, I'll take one more. Sorry.
Yep.
Oh, I'll go, John.
Do y'all use any autonomous tools? If so, how do they work, and how can they be helpful throughout this expedition?
We're wondering about autonomous tools that you might use and how they might be helpful for you on your expedition.
Yeah, great question. So that's actually a huge movement that the research world is moving into, sort of the autonomous type vehicles. One is called a wave glider. And the idea behind that is when they send a boat that's as big as ours with 40 to 50 people offshore, that's a lot of money. That's a lot of money. That's a lot of time, both at sea and also for the people who are on board. So if they can make some autonomous vehicles that can go out and do similar things that we're doing now, that cost is a lot cheaper and you can send a lot more of them out. So in the mapping world, I mentioned that only 27% of the seafloor has been mapped. One big push is to have a lot of these autonomous vehicles that can go out and map most of the world without actually sending a big research boat like ourselves. But that's just one application. Another application would be weather stations. They have LiDAR on them that they can measure the wind speed going up. So there's many, many different applications that are now sort of moving into this world where we have batteries that we can actually depend on that last a length of time. We deployed an instrument 2 months ago off the back of the boat that goes in and it bobs all the way down. So it drops down to the water column and it takes measurements as it goes. And in a couple days, it goes real slow. And then it comes real slow back up the surface. And then once it gets to the surface, it transmits that data back to shore. And it just keeps doing this bobbing, almost like a yo-yo back and forth, and sends that data. That's a great question. Yeah.
Cool. I know we have lots more questions, but we'll let you guys keep going, and then we can get more of these guys with their questions shortly.
Yeah. We'll talk a little bit about the boat and what that looks like, and then we'll continue with the questions. So we're at sea for 40 days. There's 45 people on board. So what does that look like as sort of we work and live on board the boat? So I mentioned already that we have sort of these different terms offshore. So one example would be where you guys eat at school in the cafeteria. We call that the galley, and this is what that looks like. So here's the galley offshore. So, I mean, it's basically a cafeteria, a lot smaller than you'd have at school. I don't know what your favorite meal is at school. Last night we had pizza for dinner. That's always a crowd favorite. But so you get your plate, you get your tray, just like you do. You grab your food, and then we eat in what's called the mess room. So that would be another example of like the cafeteria. So this is our example of the cafeteria. We have ice cream, we have popsicles. We always have dessert, cherry pie. What we have last night? It was almost like a rice cake. It was very good. And then we have a couple different places. So the scientists, they're going to stay. We don't call them bedrooms. We call them cabins. So this particular cabin has 3 beds in it. So there's a bunk bed and then a single bed. So you have to share your living space with different people. So just like at school, where you have to respect other people's property and other people's spaces. Maybe at the end of the day, you have to clean the classroom up. You have to put the things away, the books away, the chairs, etc. We have to do the same thing here. You wouldn't want to step over somebody's dirty socks on the way to your bed. So we have to treat the spaces with respect. Here's a couple other examples. So we have a movie room on board. So we have Netflix, Amazon Prime, Hulu. We have PlayStation, different games. I know you guys probably don't like PlayStation, but we have different options on board that people can. But we have guitars, board games, all sorts of different things. So on board the boat, people work 24 hours a day. So it's not like a normal office where people go in the morning, we come back at night, and that's it. There's always somebody up. There's always somebody working. So when you're off shift or not working, you need to sort of relax, and take it easy. So we have a reading room as well, a small little library. We have a gym that people can go to. It has a treadmill, rowing machine, weights. Let's see, what else? Oh, this is one of our main laboratories on board. So there's 40 different monitors here that we can see the scientific data as it comes in. So that's quite a few TV screens. And one of the last thing, this is where the captain works. So this is up on the bridge. This is where the captain drives the boat. I don't know if you can see it, but one thing that you can't see is a steering wheel. So gone are the days of the big steering wheel up on the bridge. It's actually a very small joystick now, almost like playing a game, where the captain can when the captain wants to drive the boat, they just move the joystick forward. The boat goes forward, back, port, starboard. They can even spin it like this in the water. We have a system called dynamic positioning that they can drive the boat like that. We'll look at a couple more pictures here. We have our hospital as well. So as I mentioned before, we're gone for 40 days. We need a way to make sure that if someone gets sick, they can be treated. So we have a small hospital on board, and we can talk to doctors on shore. We have different medicines. We have oxygen on board. We have splints in case someone breaks their arm. So we have quite a few different things on board. To 1, so we can work. 2, we can live comfortably. And if something does happen, we're able to sort of mitigate any type of injuries that happen. Yeah. So let's see, what do we want to talk about next? When you guys started school, most likely you went through some drills, right? You went through a fire drill, maybe. You went through a tornado drill. You went outside. You had like an area where you gathered. Miss Lacroix was there to make sure everybody was there. Or probably the homeroom at least. So we do something similar on board. When you guys came on board, we did some drills. Everybody tried on the life jackets. Let's see what that looks like. So here's a drill that we had where we gather. It's called a muster station, same thing as what you guys do. And this is the captain, and he's explaining to everybody how to put the life jacket on, what to do in an emergency. Here's another example of this cruise here. So everybody had to try on the immersion suits. So these red suits, if the water was cold, we're going to put these suits on. So think like a wetsuit that a diver is going to put on if they go into the water. It's thick, it's neoprene, and it's going to keep them warm, or it's going to keep us warm if we have to go in the water and abandon ship. So these are some of the things that we have to do at the start of the expedition to make sure that everybody's going to work safe. Yeah. open up to some more questions, and then we'll.
You want to show some of the streamers and the gun?
Yeah. So we talked about already the seismic data that we're doing. So how do we acquire the seismic data? So if you remember, the seismic data is that image of the rocks below the ocean. So we have two things that we do that. So we have something that we listen, and then we have to make the noise. And we deploy a cable behind us, and sometimes that cable can be up to 9 miles long that we drag behind the boat. And we put something in the water called air guns. And the air guns make a loud noise. That noise goes down to the bottom, reflects off the rocks, and then we measure it. So first, let's look at the air guns. This is going to be a video. So we were in a small boat. We were in the ocean, traveling alongside of it, and then the camera goes underwater. And if you watch closely, you'll be able to see the explosion. Let's watch that. Here we go. So did everybody see that explosion? I think you probably did, yeah. So that noise goes down to the bottom and reflects back up, and we measure it on the cable that we tow behind us. So this next video is going to be us on the open deck deploying that cable into the water. So let's watch that video. So that video there, actually, the cable was coming on the boat, but we deploy it into the water, and then when we're done, we have to pick it back up, or it's called recover the gear. I remember we had that question about the autonomous gear. So we're not doing it this expedition, but sometimes what we do as well is we deploy this the scientific piece of equipment. It's called an OBS, Ocean Bottom Seismometer, and it does the same thing that we're doing now, but this sits all the way down on the bottom of the ocean. And it measures sort of the sound of the earth. It measures the movement of the plates, any earthquakes. It's called an OBS, and we deploy it over the side at that A-frame that when we did the drone tour of the boat, I mentioned it's that gray square in the center. So we pick it up with the A-frame, we take it over the side, and we drop it down in the water. So here's the video of that.
I've been the one. You have been the one for me. Goodbye, my lover. Goodbye, my friend. You have been the one. You have been the one for me.
So that was it going into the water. Now let's watch it fall through the water past the hull of the boat. So the hull of the boat is the bottom of the boat. So let's watch this one. So as we talked about before, the water depth is very deep, 4,000 or 5,000 meters. So when we drop that, it's so deep that could take 1 to 2 hours just to get down to the bottom. That's how deep the water is here. So it's pretty deep. Let's see, a couple other things we want to talk about before questions. So sometimes when we work at sea, so this is a picture behind us. We're in an office right now on board the boat. But as you can see, the water or the seas are very calm. But sometimes it's not like that. Sometimes it's flat, but also sometimes it's quite rough. So let's see. On the table there, what is that? Is that a green bottle of hand sanitizer? There on the table in the front? Yeah. So you see how maybe there's a couple water bottles. I see a Stanley cup as well. Nice white Stanley cup. So when we're offshore, all that stuff has to be secured, because if not, it's going to fly off the table. So here's an example of a rough day offshore.
All hands
Now, what do you think? Do you think you'd rather work in calm seas or rough seas?
Calm seas.
So I think let's do some questions and then we can look at some more stuff later.
All right, I'm gonna hit up some people we haven't heard from yet. Jamal, what's your question?
My question is that all right, so about that big with the rough sea and stuff, has anything ever like slid off the boat before, like anything falling off the boat when it's like rough like that?
So question was, has anything fallen off the boat during rough seas? From Jamal.
Yeah, Jamal, that's a good question. So luckily, no. We monitor the weather pretty closely. So as the weather comes up and we see it's going to be rough, everybody will go on board. We call it all hands on deck, and we walk around and we make sure everything is secured to make sure that nothing does fall overboard. And when we're working in seas like that, we're going to wear life jackets, and we're also going to wear harnesses as well. So we're tied into the back of the boat. Let me just show you a video real quick as we deploy some gear that shows those harnesses. You'll have to look real close, but as you see this thing slide down the back, you'll see the guys working on the back with life jackets and these harnesses. Let's look. So it's probably hard to see, but I think maybe you can see the different jackets we were wearing and the harnesses.
Cool. Thanks. Samaya, what's your question?
My question is, when y'all do get stuff from your explorations, do y'all take them into like a lab and like study them so y'all can know what y'all working with and stuff like that?
So that's from Samaya wondering, like, samples that you collect, do you guys take them to a lab and study things that you collect?
Yeah, some samples. Sometimes we actually bring, rocks and mud from the bottom of the ocean. I sent a picture to Miss Lacroix recently. We got a bunch of mud from the bottom, and we put a face mask. We put a mud mask, right? But some scientists, they want to study. They want to study what's in it, and so they'll bring it to a lab, and they'll maybe look for, microbes, microorganism, or they want to look at different chemical composition. Some of the stuff that we do, we don't have to bring anything back. We collect the data, and we have computers on this, amazing ship, and we can do all the data analysis here. But yeah, there are some scientists who actually bring the samples back with them.
Yeah, we can do water samples. So we have different types of expeditions. We have some oceanographic expeditions that take water samples at different depths. So we lower this piece of equipment into the water, and at 5,000 meters, we can take a water sample at 5,000 meters, and it's not contaminated when it comes back up to surface. Another thing that we can do is we can take cores. So we can jam this big thing down into the bottom, and we can take a 15 or 20-foot rock core back to the surface, and scientists cut that in half, and they can see what the rocks or the sediment looks like down below.
I guess Miss Lacroix just showed a picture of me with a mud mask.
Oh yeah,
I did. I showed off the face masks. We have about 5 more minutes left before these guys have to go. But I'll pick on some folks I've not heard from yet. Okay, Owen, go ahead.
Like, what's it called? When y'all send something to the lab, do y'all like get sent do y'all send like unique stuff, like stuff that you don't see?
Okay, do you want to build on that? Because we're talking more about, I guess, stuff that you send to the lab. I know we were saying there's some samples from the earth. Did you have a build on that?
Like organisms, like the living things in the ocean and stuff like
Actually, that was kind of a question that a couple people had before, was like, do you guys encounter, like, what do you do with like living organisms that you encounter? What organisms have you encountered so far?
Yeah, so in general, we don't sample fish or anything like that. We monitor. So as we work, we see the different wildlife in the area: the whales, the dolphins, the sharks, the turtles. So here's an example of a picture of a turtle that we just saw. Where's it at? I'll find it in a second. Well, here's a dolphin we saw. So this is the dolphin we saw this trip. The turtle's down here. And then we take this information, goes back, and then the scientific community uses it to understand the migration routes of the different animals. But the only thing we really sample is when we do the oceanographic cruises, They sample water and they put nets in the water, very, very fine nets, and they sample plankton. So that would be the only thing that we would sort of take back to the labs. Everything else, we want to make sure it's safe when we do our scientific work.
Awesome. All right, we have time for more questions. Jose.
Has there ever been an instance of somebody falling off the board? If so, what should they do and what would you guys do?
Instance of someone falling off the boat, what would you do? And has anybody done that before? And how would you approach that? Seems like you guys had good safety drills.
So yeah. So it's safety drills. Along with the fire and abandoned ship, we have a man overboard drill, MOB. And that's everybody goes up. They go on all sides of the boat to help look. When we're working close to the side, like I said, we wear a life jacket. We also wear something called a PLB. It's a personal locator beacon. So if it gets wet, it starts to send a signal, a radio signal that the bridge can pick up. It's like an alarm, and it also has a direction so the boat can turn and be able to go back and find that person in the water. Nobody has fallen overboard here, but of course, in the broader maritime world, yeah, it has happened before.
All right, thanks. We've had time for maybe one more question. I want a good scientific question. Elvis, go ahead.
Have you guys discovered anything like that could affect our world in the future if like anything changes about it?
So wondering if you've discovered anything that could affect us in the future.
That's a great question. Yeah, so not sort of on a large scale, but every scientific study we do, every expedition we do, helps us learn a little bit more about the planet. So when we do the oceanographic work, we're learning more about the currents and the temperature of the currents and how they sort of change the weather patterns around the world. So if you ever looked at a map and you look at Europe, and the climate in Europe is as warm as it is in North America, but yet Europe is a lot higher. That's because the warm water gets pushed up to Europe and it keeps that continent warmer. So the scientists want to understand what the ocean currents do. The same with the geophysics. When we study the plate tectonics, when we study sort of the subduction zones, we're learning a little bit more about how earthquakes happen, where a potential earthquake could happen, and that's sort of helping us understand the greater world. One real world application of what we do, maybe to answer your question, is to understand tsunamis. So when an earthquake happens and you have an underwater landslide, we want to know what the potential of a tsunami happening is. So we have these sensors all over the world, specifically in the Pacific Ocean, that when an earthquake happens, it alerts us and says, hey, an earthquake just happened. Be on the lookout for potential signs of a tsunami. So alerts go out to Hawaii, to the West Coast, and they'll start to prepare to see how serious this is going to be. So it just doesn't happen without anybody expecting it.
Awesome. Thank you so much. We do have to start wrapping up. I'm actually just passing. We love these certificates. Thank you so much for these.
Oh, great, yeah.
Passing those out as we wrap up.
Yo.
Great.
That's it. That's great.
All right, Ms. Lacroix.
Okay, well, thank you very much. We'll end the live stream then. So I appreciate it. Thank you.
Yeah.
Thank you guys so much. We appreciate you.